Hello everybody, this is Hussein Nasser. In this episode, we're gonna talk about mesh analysis. So I will start with what is circuit. Okay, so circuit is a lot of wires, a lot of junctions, a lot of components that much size or this small size. This circuit has current flow inside. So that current gonna make voltage across the component, gonna be resisted by another component which is called resistors. So when you ask about a circuit and you ask to find these constants, what you're gonna do? You're gonna use some of our methods of analysis, which we will talk about in this episode. Is the first one, analysis. So we will start with the basic circuit, but before that, I want you guys to know what is the difference between loop and mesh. So if I had this circuit and somebody told, oh, what is loop? Okay, loop, this is loop. So loop is a starting point, for example this point, and end at the same point, which is this. For example, I will take the path, this path. Okay, so this path I will call loop, but this is not mesh, because loop can contain more loops. This is my first loop that contains this loop, first one, and this loop, the second one. So I have two loops inside one loop. But mesh, what is mesh? Mesh is just one loop. So this is a loop and it is mesh as well, because it's just one loop. So that's the difference. You have to take concern and don't be confused with that. Okay, so I will start with first circuit. We're gonna take the circuit. Okay, so this is our circuit. So this is R1, this is R2, this is R3, this is E1, this is E2, and this is the ground, as you all know. Okay, so first of all, I look at this circuit and I think, how I'm gonna solve it. I have resistors, I have voltage sources, and yeah, everything seems not very complex. So we will start. First of all, you have to determine your mesh. Remember, mesh is just one loop. So this is my first mesh. This is my second mesh. Okay. If somebody asks, okay, Hussein, why you put the arrows in a clockwise direction? Why didn't you put in anti-clockwise direction? You can put it in either two directions. There's no difference. So this is my loop or mesh. Remember, loop, which is containing two meshes, two or more loops, and mesh is just one loop. Now, the direction of the arrow is my direction to this direction here is the direction I assumed the current is flowing in this circuit. So that means on this resistor I have a voltage, but the voltage, you know, is positive, negative. You have to know where to put the signs, okay? Depending on the current direction, look, it starts from here, go upward, so whenever it enters the resistor element, you're gonna put plus. And the corresponding side is not minus, okay? And continue the direction of the arrow. Now you come here. Look, here is something you have to take concern about. This element, this resistor, which is R2, is a common resistor between two meshes. So, okay, Hussein, it's common between two meshes. Where is the signs? Where I'm gonna put the signs? The plus here, the minus here, or the plus here or minus here? Where I'm gonna? How can I know where I put my signs? Okay, good. You have to assume that if this assumed current is greater than this assumed current, the plus sign will be above and the minus sign will be in the bottom. But if this assumed current as a magnitude is larger than the first one, so the current is flowing in this side. You have to imagine that when somebody is pushing me, I suppose nobody can push me. So if he's stronger than me, I'm gonna back. If I'm stronger than him, and I will kick his ass. So that's it. So this is the plus, this is the minus, as I suppose that this current is greater in magnitude than this one. Now, the first loop is over. The second one, I look at my assumed current. Okay, I don't play with this resistor because I already put the signs on it. I look at the R3. So the current direction is going up, 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 and then down. So it's enter. Where is enter the resistor element? I will put a plus sign and the corresponding negative sign. So that's the second. The second step is over. Now, you know that the battery, the longer lead or the longer line is a plus, and the smaller one is minus. And here is the same plus minus. Now we have to write the KVL equations. KVL equation. I suppose that all of you know what's KVL, what's KCL, because it's very, very elementary. So KVL, look, KVL, which is Kirchhoff voltage law, for the first loop. Okay, for the first loop. Now, plus the arrow, I make my loop with the arrow. The minus to the plus with the same direction with the arrow. So E1. The arrow is going up, but here I have plus, so it's against the arrow. Minus VR1. Minus, because the plus is against the arrow. Then I continue my loop. Now, here, R2, but this is R2 as a resistor. I want the voltage on the R2. The voltage on the R2 using Ohm's law is equal to IR, the current multiplying to the resistor. And you remember that I assumed that this current, this guy here, has a magnitude greater than this guy here. So that means, and the arrow is against the plus sign, minus VR2. But what is VR2? VR2 is the magnitude of this resistor multiplying to this current minus this current. Why minus? Because it's a common element between two meshes. You know, here's the current and here's the current. The the current flow in this branch will be the sum of forces, like Newton forces. So this current minus this current, because this guy is greater than this guy. If this one is greater in magnitude than this one, then the equation is going to be this guy minus this guy, and like that. And the signs will be reversed on the resistors. So VR2 is R2 multiplying to I1 minus I2. And all of that is equal to 0. So that is the first loop of the mesh. Now, we move to the second one, the second loop. The equation of the second loop. We start from here, as before. Now, we have the arrow, it's going upward. Here's the arrow on the second first loop. So it's with the sign of the component, so minus plus, with the sign. So VR2, it's not minus, here is minus because it's against. There is no minus here. Now, to the R3, the arrow is going up, 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 then down. So it will face the plus first. So it's minus VR3. Then it's going to down, 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 and face the plus of the battery, so it's minus E2. All of that is equal to 0. But, I'm saying, what is VR2? VR2 is the same as this one. It's R2 multiplying to I1 minus I2. But what is V3? V3 is just, here is V3, is just R3 multiplying to I2. That's it. Okay, now you have two equations with two unknowns. Using the matrices, you can find the constant. And that's it. That's the basics of the mesh analysis. I hope that you have enjoyed this lesson and get and I will give you some time to recap this information. Then we will continue.